Everyone. So today I'm going to be talking about resonance again. This is going to kind of prepare you for what I'm going to talk about later in the video, which is our kinetic and thermodynamic products. Kind of happens through mechanism and deals with resonance. So to start off, we're going to talk about like resonance and how you can do it looking at different structures. If you're not able to find this form anywhere, but if you just want to like practice, you can draw these on your own, kind of follow along, pause the video, do it with me. But so one of the big things is with resonance is kind of just knowing what the basic moves are. So with these right here, so we have a positive charge, and then we have a double bond. So an easy move is what I like to call a door hinge. So like right, just like that, we're able to move it over there, just kind of move the double bond, and the charge is gonna switch positions. So what that looks like is with our double bond, we door hinge it over there, and then that positive charge shoots around right there. So our resonance structure looks something like this, just like that. And then so for our next one, we're going to do the same kind of move. This one's not as obvious to a lot of people because it's not in the ring already. But what we're going to do is move that double bond right there in, and our charge is going to shoot up to the carbon up there up top. So our next structure, or the last resonance structure for this one, looks something like this. So there we have that carbon, our positive charge. Keep that double bond that we made or that we moved in our first resonance structure, and then move the other double bond inside the ring. And so when kind of deciding which ones are the most stable, you kind of base that on charge, how many pi bonds there are, various other things like how close the charges are to each other, if they're on electronegative atoms or not, if you have unfilled octets, things like that. So in this case, our charges are the same. There's no real difference besides um, our stability of our intermediates. And so looking at that, we look at our carbocations. So here we have a 2' carbocation. Here we have another 2' carbocation. And then here we have a 1'. So as we know, 3' carbocations are the most stable. Then it's 2', then 1'. So with this, our two most stable of the three resonance structures are going to be our first two, since they are equal overall, leaving out that last one. So our next resonance structure, we have two kind of different moves we can start with. So we can either form a double bond between the oxygen and the carbocation using the lone pair, or door hinge that double bond. So I usually like to door hinge first. It's one of my favorite steps for resonance. So we're just going to do that. Bring that charge around like that, and draw out the structure. Just like that. So that's our first structure. Um, Nothing crazy going on right there. But so the next one's a little bit more complicated. A lot of people don't really see it at first, or even think they can do anything else, because now the resonance structure that we created, there's no move from that one. But what we actually have to do is look at the original again to make our next structure. So doing that, we need to look at that positive charge and the lone pair of the oxygen. So what we're going to do is now with the orange, this is our second step. We're going to bring that lone pair in, and then that positive charge right there is going to shoot up to the oxygen for our second structure. So drawing that out, leave our double bond like it is in the original, like that. We don't want to leave it with the second one because that would not be the correct structure anymore, since we've moved it from the original. And just having that positive charge right up there. So that's our third resonance structure for this one. So just being careful when you're on the test, making sure that, okay, I've done my one step, I don't see anything else. Go back to the original, look there, you see something, do that. And now when deciding, so here, all the charges, each one has a positive charge, just the one charge. Um, they're in varying places, varying number of pi bonds. So that's what we're gonna look at first, is the number of pi bonds. So this one over here has one pi bond. This one also has one. pi bond. And then this one actually has two pi bonds because we made that pi bond between the oxygen and the carbon, and then we had the original double bond. So even though that charge is on the oxygen here, this is actually our most stable um, of the resonance structures in this case. So now we're going to move on to our mechanism for test three. So this is a good chance of what it's going to look like on the exam. We're going to have the addition of HBr or HCl or something like that. And then we're going to have our diene like this. So this is a conjugated system. And a big thing for this is resonance. And so when we the double bond attacks the hydrogen, it forms a carbocation. It's able to do resonance. So then we get two different products from each alkene. And then showing all of those steps. And then at the end, deciding between the thermodynamic and the kinetic product, which we'll get into once we get through the mechanism part. So first off, what we're going to do is we're just going to go into attack the hydrogen right there from that double bond, which is just going to break that bond, returning the lone pair to the bromine like that. So now we're going to get our first right here. So that alkene, keep that one on the end right there. Our positive charge goes here, and then our little hydrogen got added right there. You don't need to show the hydrogen. It's implied in this case. Kind of do whatever makes your heart happy. So the reason we put the positive charge where I did and not where the hydrogen is so that we can actually resonate between the two. Because if I put it where the hydrogen is, then it wouldn't be a conjugated system anymore, and there could be no possible resonance because the other double bond is too far away. So now with our resonance, when you draw this arrow, you have to make sure it's drawn double-ended just the way that it is right now. If you draw one forward direction or if you draw a half arrow, um, you'll lose a point for that on the test. So our next structure is going to look something like this, just like that. Moving that positive charge to the end of our chain like that. So now we have our bromine just kind of chilling up here, and we're going to use it to kind of attack both. This is not happening simultaneously necessarily. It's just a way to show it easier than drawing two separate bromines. But do whatever kind of makes you more confident in your answer. So then we will show our products down below like this. Just like that. It's our first product. Then our second product will add where the other carbocation is. Just like that. Make sure not to forget the double bond here. Always check your work, make sure you're carrying everything down. It's really easy because there's a lot of kind of steps going on here to miss things and forget things and stuff like that. So this is our product one. If you see it matches the top, and then this is our product two. Once again, it matches the top of there. And so this was reactions of alkene A. We can put that over here in the corner. You don't need to write this on the exam or anything. Just helpful to kind of note. This was alkene A, and now we're going to break alkene B of the diene. So we're going to go down here and pretty much just do it again. So we're going to attack the hydrogen, turn the lone pair, and then start drawing out our resonance structure. So person's right there. Our little hydrogen gets added right there from the original double bond. And then we have, once again, our resonance, drawing those double-sided arrows like that. And then we're going to have kind of that door hinge movement that we've been having. A positive charge will go right there. So now we have our bromine once again, all negatively charged, and we can add it or attack our carbocations again. Then we show the formation of the product. And we're just like, this is fine for this, no double-sided arrows here, because that denotes resonance, and that's not what we're looking for. Now we're just showing the product, so this is our first one. This would be product three. We go up top and look, product three right there, and our product three looks the same, and then our product four, just like that. So that's pretty much all you have to show for the mechanisms themselves. Um, Showing your resonance arrows, showing the formation, breaking of the double bond, and stuff like that. We get you full points in that stuff. So that's about probably 16 of the 20 or so points that this page is worth. And then these two bottom questions are worth four more or something like that. So now looking at our products, we can start looking at the kinetic versus thermo. So a note, kinetic products are always 1-2 addition products. And so when I say 1-2 addition, I don't mean adding to the one or two carbons necessarily. I mean adding to the chain, like starting. So for alkene A, this is our 1, 2, 3, and 4. So it's not really name related like we've done with IUPAC and stuff. We're looking at the start of the double bond and then that system after that and stuff. So looking at that, um, our product one up here would be our 1-2 addition. If we look here, like technically a hydrogen was added right here. So this would be the one and then our two. And this would be a kinetic product. And then looking over here, so thermodynamic products are usually the 1-4 addition products. Um, they don't always have to be 1-4 addition. They can also sometimes be the 1-2 addition products, depending on the stability of the products, which we'll get into in just a second. But so this one, if we look at the numbering, we have our 1, 2, 3, 4 hydrogens there, bromines on the four. So this is our 1-4 addition product. And in this case, this one is going to be our thermodynamic product. So if we want to decide thermodynamic, we look at the substitution of the alkene. So like before, if we just draw it like a regular alkene, so if we have, let's say, a ring like this, then we have that right there. So that alkene attaches to two carbons over here. So this would be a di-substituted alkene. Then you start adding carbons off of it, then it could be tri and then tetra. So the most stable is the tetra substituted alkenes, and then obviously your mono substituted being your lowest. So we look at product one, it's attached to one carbon over here. So this is mono substituted. And then looking over here, our product two is attached to 1, 2, 3 carbons. So this is tri substituted, which is what makes it our thermodynamic product in this case. So now we can move on to products three and four and kind of decide which one is our um, kinetic and our thermodynamic product. So like I said up above, Our kinetic products are always our 1,2 addition. And in this case, so since we're breaking the other alkene, we're going to number starting over here. So it's going to be 1, 2, 3, and then 4. So the numbers are just relative of where the double bond breaks or starts or whatever, however you want to think of it. Um, you can kind of follow along with this and help it make sense for you. So in this case, we're looking at it, our product 3 right here, we get a little H. This is 1, 2. So our 1, 2 addition. So it's our kinetic product. Then, okay, we come over here to product 4. So once again, we can label, oops, we'll label this 1, 2, 3, 4. And so our hydrogen right there, still going to be on the end, and then our bromine's on the 4. So this is our 1, 4 addition product. But to decide if it's thermodynamic, we have to look at our substitution of our alkene. So in this case, we have 1, 2, and 3, just like that. And then on this one, we have 1, 2, 3, and 4. So this is tetra substituted, and this is tri substituted. So when we're looking at stability, the tetra substituted is the more stable one. So even though that product 4 is our one addition product, product 3 is actually both our kinetic and our thermodynamic product. So kind of something to note when thinking about the products. Our kinetic product usually likes cold temperatures, it has a lower activation energy requirement, is less exothermic. And then in comparison, thermodynamic products are, they prefer like warmer temperatures to react. They have a higher activation energy and are a little bit more exothermic than kinetic products overall. So like in this case, product 3 is both the kinetic and the thermo, and then product 4 is just kind of chilling there. Doesn't really get a name in this case. But now we move on to the end. So we're looking at which of the above products is the kinetic product. Note there's only one. And so if you remember, we decided that product 1 and product 3 are both kinetic products. So now we have to decide which one of the kinetic products is the most stable product. And that'll come down basically to which alkene was more reactive. And step B, just showing alkene B really quickly. So to decide which one is more reactive, I like to look at the intermediates. That's kind of where you see that carbocation stability. So whichever one has the highest level of carbocation. So let's say we have a 3 prime and a 2 prime, or then a 2 prime and a 1 prime. The alkene that created a 3 prime and a 2 prime is more reactive, or is more stable, which is therefore more reactive, and is going to be the one that forms our kinetic and thermal products. So we look at our carbocations from our resonance structure. So here we have a 3 prime. We have that 1, 2, 3, pretty solid over there. Then here we have just that 1. So this is a 1 prime. Not great, but let's see what we have down below. So here we have 1, 2. This is a 2 prime carbocation. And here we have 1, 2, 3, 3 prime. So overall, alkene B, or however you want to label it, is the more reactive alkene because the carbocations are higher order and therefore more stable. So even though product 1 is a 3 prime carbocation and forms that 3 prime kinetic product, it doesn't matter. Since alkene B overall is more reactive based on the stability of the intermediates or the carbocations, that's the one we're looking at. So now we can easily answer the bottom problem. So we've already kind of written out which one is the kinetic product. And in this case, it is going to be product 3. And then we've kind of already worked through which one is going to be our thermodynamic product based on the stability or the substitution of our alkene that's still there. And we also decided that product three is the thermodynamic product. So the stability of the intermediates kind of works the same for the thermodynamic product. Basically, whichever alkene is the most reactive or most stable is the one we look at for both products. So in this case, product one and two would never be an answer for the bottom because we decided that alkene B is the most reactive. We only look at three and four once we make that determination. And a question he could ask on the exam is that he gives you a couple resonance structures and says, okay, which alkene is more reactive? Or he could even include a question like that here and say, okay, tell me which alkene is more reactive. So if you understand that, you'll easily get the bottom part right here. So kind of a recap on kinetic products and thermodynamic products. The kinetic products are always your 1-2 addition products. Um, it's always going to be that way. It's always going to add to that 1-2 position. And just remembering that it's not relative to the whole chain. It's wherever the double bonds start. So for alkene A, we broke that one, and that was our one. Started out in 2, 3, 4. Alkene B starts at the other end of the chain and is our 1, 2, 3, 4, the other direction. So just keeping note of that, knowing that a lot of times your thermodynamic product is your 1-4 addition product, but not always. So if you see 1-4, make sure you check your substitution of your alkene because that's the kind of decider for your thermodynamic product. As we saw in for alkene B, this product three was both the 1-2 addition and kinetic product as well as our thermodynamic product, even though it was not 1-4 addition. So overall, just kind of taking note of this, including your double-sided arrows, showing the steps, making sure that you're adding your charges to the right spots. Um, I hope this was helpful overall. This is really important to know for the test. If you have any questions, feel free to kind of reach out, email us, come to office hours. Don't feel afraid to like ask questions. I know there's a lot of content to cover before the exam, but we're here to help. So I will see you all later.